and a warm welcome to today's hands-on bootcamp where you will get to build a fully working application in just under 30 minutes. I am 𝗖𝗲𝗺𝗂𝘁𝗵𝗂 and I'm the Director for Community and Partnerships with OpenWeaver. OpenWeaver is a SaaS technology company supporting over 1 million developers worldwide build their ideas faster by reusing open source software. Our vision is to reinvent digital realization. Very simply put, we'd like to improve the way applications are built. We do this by investing in a unique combination of both public domain knowledge and artificial intelligence. So coming to today's bootcamp, this is an integral part of our OpenWeaver community initiatives. The OpenWeaver community is a body of like-minded technology enthusiasts and open source contributors who have come together with the vision of contributing to the world of open source and sharing how complex use cases can be developed by reusing open source. Over the last few weeks, we have run several such open source development bootcamps on a variety of topics, such as building your own AI-powered e-commerce site, building your own ChatGPT, building a breast cancer prediction engine, building an object detection engine, basics of Python programming, and many more to come. Through these bootcamps, you will realize that technology does not have to be complex and definitely does not have to be developed in silos. You will see how you can take a solution that is pre-built, in fact pre-built by many people in the world, and then you can build on top of it and share it back such that your solution can now be accessed by many other people in the world who can then further build on top of your ideas, thereby accelerating this virtuous cycle of innovation and also helping you scale your ideas and bring it to life much faster. So with that brief introduction, I will now welcome our mentor for today's session, 𝗥𝗲𝗀𝗂𝗂𝘂𝗶, who is a senior developer advocate with OpenWeaver.
Welcome everyone to today's session on object detection. So we will discuss how object detection, which is for which we are going to use computer vision as our primary library, we use to detect a particular image or an object within, say, a big, a complete image. So today we are going to discuss it in detail. Let's get into the agenda for today's session. First, we'll talk about artificial intelligence and how with open source you can do amazing application development. And then we will discuss the computer vision concepts along with some interesting coding exercises. Then we will get into our object detection solution under 30 minutes. So before we go ahead and discuss the concepts for this session, I would like to showcase to you what are you going to check out in today's session. So just not detecting objects from a given image. I'll show you something very interesting for which you will be developing a kit yourself. I will be disconnecting myself from for a minute so that I can use my camera for object detection streaming. And this is the code that we will be running today, or I would say the notebook, where we will be actually doing a real-time streaming. So as I have run this solution, just to showcase you what exactly is going to be the use case for today, we'll just let it run. And how with this today's real-time object detection, you can use it for surveillance. You can actually use it for detecting, your car number plates, right, in traffic detection, or I would say in order to control the traffic. Okay, so I can have this detection already. I hope I'm able to, you guys are able to see me on the screen in the object detection, and I'll show you that how within an image, within the notebook, it is able to detect this motorcycle with a certain score, right? With a certain accuracy or with a certain percentage confidence score, It is able to say that there is a motorcycle, and then it is also stating that I'm a person with some 80% probability. So when the image becomes more and more stable is when your model is able to properly state. So we'll also detect other such objects. Let's say yes, it's a cup, and many more such examples. We are going to demo the same. This is going to be a use case for today. So I hope you guys are interested in developing one of your own. And so for the same, let's get started. Minute before I can reconnect myself here on the cam. Okay. So yeah. So about today's topic, we want to talk about the ubiquitous nature of artificial intelligence, how it has influenced our lives, and how it has completely changed things and how we work around with these things today. So we'll talk about this use case of object detection, and as we discuss this use case of object detection, we will also talk about how you can develop a similar solution, a real-time object detection, by simply setting up a kit. So let's go ahead and start setting up the kit. To be able to set this kit that I just showcased you just have to get onto the community platform wherein you are viewing today's session. And on this platform, under the resources section is where you will find a Kandi one-click kit. Click on this button. It will take you to the kit page. On the kit page, you have the information on the kit as well as the deployment information that you can check out for setting the kit. Let's go ahead and download this one-click installer. This will get set up into the local system and it is a zip file. So just say extract all. Very important to extract this batch file before you start setting it up onto your systems. So double click the extracted folder, double click this batch file, say more info, and then go ahead and say run anyway. So since I have one of the instance already running, you see I showcased you the output. That's why it will ask me that would you like to go ahead and uh, run another instance. For you, it will just follow the steps by setting up this Microsoft Visual C++, Python, and all the other requirements will automatically get set up into your systems. And once it has finished, it will say repo is available at a certain destination, which is your C Candy kits, wherein you can find this kit in the real-time object detection. And then once it has completed, it will ask you, would you like to run the kit? So you just have to say yes. So let this setup finish till 100% for you. In the meanwhile, we will discuss the concepts. Okay. So I said that artificial intelligence is nowhere to go. It is something that has touched our everyday lives and has become the most. I mean, it's one of the most uh, not essential but something that is to be here forever, and hence we are going to talk about how it has helped in object detection algorithms that are extensively being used in every field today. Also, we can detect any object from a given image or video, or do a real time you can capture your real time movements and detect any type of object. In fact, you can also go ahead and check out the minutest of details within an image. So let's say we want to check out the brand name of the car or the logo of the car, like the number plate of the car. That's how you see that even the governments all around are able to get people, get hold of people and are able to do the surveillance required to control the traffic. So the deep learning algorithms are what that have helped in establishing interesting pre-trained models. So important is that these are heavy models and require a lot of data. These are data hungry models which need to be trained with a large amount of images, and to be able to do all of that onto your uh, personal system is not something which is viable. So we use a model that is pre-trained, already trained on a certain set of data, and based on the set of data that it has already been trained on, we use that pre-trained model. We'll be using the YOLO model today, and that model will is what will help us capture the real time webcam feed of your system, or let's say of your camera that you may have set onto your systems. So yes, alongside with interesting a large amount of data, and then the models developed around those data, we are able to work around a interesting use case. Next comes is the necessity for these cloud, your edge platforms. So cloud computing is something which is helping you do most of the task online. You don't have to wait and do everything onto your local system, but most of the computation actually takes place onto uh, third-party servers, onto the cloud servers, thereby helping accelerate your computation, or I would say thereby accelerating the way in which these models are run. So cloud edge, with the invent of these technologies in edge computing, cloud computing, and microcontrollers, this has enabled for us to see the great inventions like ChatGPT, Delhi, and so much more going forward. We'll talk about how you can develop quickly with open source. So the interesting thing is all these tools, the use case that we bring out to you today is all open source. Hence, you can use it, modify it as per your own needs. You just have to check the license requirements. So depending on whatever we give you as a solution, that is all permissive license. And as a part of a community initiatives, you are able to check out interesting use cases with us. So that is how open source is very relevant as of today. You do not need to start development from scratch. In fact, we see that there are more than these 200 million plus repositories that are available, and with these more and more repositories that are getting available, you can take a code, build on it, and with the help of a vibrant developer community, you can actually get support of many developers and build a solution thereby in very less time. Also, an interesting fact that 90% of the world code actually, the world code consists of open source. So, open source is here to stay, and we've already seen how it has revolutionized the way in which we now work and develop applications. So now let's move into the object detection concepts for today. So we'll talk about computer vision, what and how computer vision is different. You feed images and video as data into your computer vision models, or into this technology where we are willing to train the machine in a way that the machine is able to see as we humans see. Similarly, the machine is able to see, observe, and understand. So the same intelligence, or I would say the same vision that we humans have, we want to put the same into the machines. So what library or what tool helps us do that? We use the computer vision as one of the essential technology that helps us provide a vision to your machine. So it's especially used in the driverless cars. It is used in security purposes for doing your traffic surveillance, and from this to so much more. So we you see that the machine is able to then see, observe, and also understand. And we saw that our model was able to give us a decent confidence score that whatever it is detecting, with a certain confidence score, it was able to state whether that person, like based on the data set that it got trained on, that this is a cup, this is, let's say, a motorcycle, or a person. Okay. And then we say that it has applications in classification, in detecting, in detection, and in tracking. So even vehicle tracking and all of that can be very much done under the computer vision. So how do we go about working around such a solution? There are two important essential steps. So for the first step is image classification. So you see that the first image that you see on the left top, that has person, or okay, there are many multiple people in it. So one thing is just to identify what the image consists of or what is the image about. So that one thing is image classification, basically telling what exactly your image is. And then the second thing is object localization. So within this image, this is an image of people or person, and then within that image we want to state whether exactly where that particular image is. So the image of person 1 and person 2 and multiple such persons are easily being located. So a combination of the what is object detection? A combination of classifying the image, what category of image it is, and exactly within where exactly in the image the object is located. So these two steps are what help you in object detection. So next we talk about the flow of the object detection. So how does it exactly happen? So basically you give your model an input image, okay, and then based on the input image that you give it, it actually extracts, or I would say, all the essential features from that image based on the color, hue, and so many different features of an image. For identification, it tries to create or extract these features of the image and create a map. So this feature map is what is being extracted, and based on that, the different features are then discriminated from one another. So the reason for discrimination is each image needs to be uniquely identified. So supposedly, to be able to identify a person as a person, we know that a person has certain set of features. So those feature maps are identified, and then the same are being enhanced so that we are able to properly discriminate two images from one another. And then the same is being passed to the backbone of your neural network. So this is all working on your neural networks. This exactly neural networks are similar to how your brains function, how you are able to make synapses and decision making happens into your brains. So similar pattern is being followed in artificial intelligence neural networks, wherein you have an image that gets captured onto the retina, and then all the essential features are being extracted. Those are extracted, and then the further step is to be able to discriminate them suitably, so that based on the discrimination that is done, the enhanced features are then used to make prediction by the model. So that is those are the four essential steps that are being followed for object detection. Talking about the neural networks that are used for object detection. So there has been a great history of models that are being used. So it started with your RCNN, or let's say in 2014 is when your RCNN came, and when this RCNN came, uh, things started moving and object detection became one of the key things. But since it was the very beginning, it was those sorts of models which followed a approach wherein a region was checked, a potential object was checked within a region. So a selective search algorithm was used. And what sort of a search used to be happening, what sort of a search used to happen on an image was a large number of regions used to be proposed, and by grouping the different pixels, like your the common color, texture, or other visual cues, all of those were then selected. And then the next step was again the same, I was saying, feature extraction. So a deep convolutional neural network, CNN, is used to extract the features from each region. So first thing is where the object is located, correct? So that locating of the objects was the step one, where the regions were proposed. Then feature extraction was the second step, and then the third step was your classification of the object and the bounding box. So we were using initially the support vector machines to classify each region that was proposed to have an object. Okay, into having an object or not having an object, into two classes. Okay, a region to have an object or not have an object. A bounding box regressor was also trained to refine the location of the object within the proposed region. So these were the steps that were followed in RNN. But the only problem with this amazing state of the art was that it used to happen all in non-real time. All of this detection of the region and then the image, and it used to be computationally really expensive and slow. So then a lot of variations to this were proposed, such as your fast RCNN, which replaced your SVM with a softmax layer, and then your fast RNN had a region proposal net at RPN to generate regions from like in an end-to-end manner and also in real time, so that there was good speed and accuracy that the model was able to provide. And then next came was your single shot detector. So your SSD, which is based on a single neural network, it could detect objects of different sizes and aspect ratios. It works by predicting the class of each object and its location using a set of predefined anchor boxes. So SSD and YOLO and RetinaNet, all these models when they came, they actually revolutionized the way in which object detection works. They made it really quick and easy for the detection to happen, and all of it actually happened in real time. So that was what was very important. YOLO is again a single stage detector. What it does, it tries to create a bounding box. It first tries to put everything in the form of cell, as you can see in the image. All these are put in the, so it's just the image is first divided into this cell form, and then from one end of the image to the other end of the image, you try to get different regions, or I would say bounding boxes, which the fatter the bounding box is, the higher the probability that it contains a suitable image. So based on the you only live once model, we will try to do a real time object detection today. And with RetinaNet is also similar in terms of if we talk about the efficiency that it provides. It's also a signal stage detector. We don't have to go into steps, we don't have to wait for the result. The imbalance problem that used to happen, let's say when we are trying to detect the objects, sometimes you would see that the model, because of a lot of movement in the image, the assigning of higher weights happened here, so that you were able to detect images properly, and you had some really interesting solutions and amazing performance on rare class of objects. So when we say rare class of objects, some objects are really complex to be determined. So with these YOLO, RetinaNet, these were the models that were helping to get to better object detection. So this step is also very essential, your image augmentation. What happens in an image augmentation is you actually work around your, you break your image, you crop it, you resize it, you rotate it, flip it, scale it, zoom in and out. You make changes to the image such that when you train your model, when when we are using a pre-trained YOLO model, but when this model was trained, when it was first created, so a lot of amazing images had to be adjusted in a way that it is able to train the model well for detection. So the zooming quality, the adding of blur, noise. So we explicitly add these blur and noise so that when there are images which are not well lit, the regions in the image which wherein there is darkness, those could be accurately detected during the testing, or once the model is being trained on similar sort of data. So we do a lot of augmentation or image changes, or we try to change or make the image suitable for training. So what are the popular data sets that your models are, run on? So one is your Coco and another is your Pascal. So we would want to just discriminate amongst these very popular two data sets. So in one of these data sets, at the end of the day, the way in your model work will is primarily dependent on what data set you have used. So one was in this JSON format, another is your XML format, and the full form for Coco is Common Objects in Context, and Pascal was also based on the Pascal Visual Object Challenge that was launched. Everything in Coco is in a single file, and whereas for Pascal you need a file per image. The separate files are created in Pascal. In Coco you can have a single consolidated file that you can use to train the model, and then your bounding box will have your parameters, or I would say your x and y, the four parameters like x, y, width, and height to define it. And in Pascal form of dataset, we use xmin, ymin, xmax, and ymax. So just to differentiate these two essentials, Coco was one of those datasets that is used to train the model that we use today. So now, before we go ahead and implement the solution, I hope by now your solution should be open in front of you. If not, I'll just ask you to go ahead on the community platform and also check out these interesting polling questions that are available. You can interact with these and let us know your views on the topic we are currently discussing by logging to the community platform. So, getting back to your Jupyter notebook. So, I'll just restart and run all. I'll have to disconnect myself again. So, to be able to showcase you the results on Jupyter notebook, I just have to disconnect myself from there. And as my model is loading here, we will do some very interesting two code snippet exercises that you can also follow along. So just say new notebook, open a new Jupyter notebook here, go back to the community page. You see that there is an option to go on to kandi.openweaver.com. So this helps you search for interesting applications. Let's say I want to do an exercise on blurring an image. So the first exercise that we have also given the search for, how you can blur an image using OpenCV. So I'll make a search, make image blurred using OpenCV. So just make a search here. This gives you interesting code snippets. So these code snippets, if you see, are amazing examples that you can use to quickly do an exercise. So I'll just copy paste this first one itself, go on to my fresh notebook, paste this code here, and I hope I'm audible. Currently, I'm just removing whatever code is an extra code. Okay, just removing a code which is extra and then rerunning this. So you see that this is some sample image that is showcased here. So let us just get an image that we would want to work around with. So within the kit installer itself, if you go to this runs folder, detect folder, we'll get this image that we have used in the solution. Okay. Hello. Sorry guys, I felt that I had this issue of voice. Sometimes this happens when I disconnect. Okay, so yeah, we get to our image. I just copied it from this folder. You can select any random image that you would like to blur. Okay, and as you get to this image, just copy paste this image where you have your real time object detection. Within the C kandi kits, you will have this folder. Paste this image. So it has this name 𝗖𝗲𝗿𝗁. Okay, and we'll also check the format of our image. So it's in JPG format. Okay, so yeah, sorry, just paste this code here. Let's just start from scratch. We just have to choose this first code snippet search. Okay, it is provided here. Copy paste it, add it to any fresh notebook. Okay, okay, we see that this is a duplicacy, so we'll remove this. And then my name was 𝗖𝗲𝗿𝗁. How did I got to that image? Find any suitable image that you would want to blur. So I got it into the same folder in C kandi kits real time object detection. Okay, within this folder, and also check the format of your image. So is it a JPG file or a PNG file? Very important to note. So I'm just going to use the same JPG file, and let's see how it will work. I've just used Control Enter to run the code. It's taking it a while. Okay. Okay, just restart and run the entire kernel once again. So sometimes these are some heavy, yeah. So, okay, let me show this. And this is the original image. Okay. And the one which I just minimized. This is one of the images, and this is the blurred image. So I hope you are able to check that this is how we can blur an image. So now we'll quickly go ahead and stop the kernel and just get a new cell here and do the second interesting exercise. So you can get quickly by just convert an image to grayscale. Click on this search result here, copy the very first result that you see, paste it, and just see that you need to rename it with the image that you have put into this folder JPG. And we will just say Control Enter, close this as well as this. Restart the kernel once again. So you see that this image has now been grayscaled. And this is we can give any name to the grayscaled image. So yeah, suitably, this is how you can simply convert an image, colored image into a grayscale image. So with these two interesting coding exercise, we now quickly move to our notebook. Let's try and understand how this code is working. So first of all, we imported all the necessary libraries. The essential library here that we use was your OpenCV and also your Torch, PyTorch. And then we loaded our pre-trained model called YOLO version 5. So this is developed by Ultralytics, and we've also loaded it from the torch.hub, and we said yeah, set it up. We loaded it. It had got some 213 layers and amazing parameters. After it got loaded, we just picked up any random URL. Okay, this is not necessary to be picked, but this is something which was given by default on the Ultralytics website itself. And then we just saw this first image. Now within this image, we want to make a prediction. Okay, within this image, we want to make a prediction. We are printing it here and saving it as well. So interesting thing is, just in case after this fourth cell you are getting any error, just copy paste the path of the image that you get. Copy it here and paste it just before this image file detection. If you have not already done, and you may are any of you if are encountering any errors. So further, what we've done, we gave this image to the pre-trained YOLO model, and now within this image we want to check. So this image, this is a little sideways, and this person is standing straight, and hence you see a difference in the confidence score. So the more the model has, this is a straight face, this is a side face, as well as this tie, it was able to detect with a more confidence score of 0.68, and this one with a lesser confidence score. So depending on the image, the object within that image, the detection happens. So here is where your code is for your video capture. Now we want to capture the live feed, and we have used these two. Within the continuous to variable, what we are trying to do, we are loading your model on the captured image. Okay, this NP variable. So whatever is your feed, we are actually applying your model onto the feed, and then two things we are getting from it. One is your confidence score, and another is the label. Okay, so confidence score, let's see a quick example. So it is able to detect a person. So the label is person, and this is the confidence score for the person. Similarly, the label is chair here, and then the confidence score with which it is able to say chair. Let us see what all it can detect. Can it detect something as basic as, so it's getting a little confused. Okay, see, with multiple objects, it's sometimes setting it as a bit of toothbrush. It in fact tried to detect it as spoon, baseball bat. So then it depends. It was able to detect fork. Yeah. So since two of the different objects are also getting overlapped, it is accordingly trying to give us the result. So this it is able to clearly detect with a very good confidence score that is a cup. And then yeah, so it's able to detect the cell phone with a very good confidence score again. So yes, this is what our model is. You don't have to worry about these different four parameters that we already talked about when we are training our model. You mentioned the different parameters, your image, and the different points of your image, as well as the thickness, the color, and this is for the bounding box, the box that you saw around the object. Okay, so that is what is being read, and then the labels and the scores are accordingly being showcased to us, and then it tries to locate different objects within the loop. It completely keeps checking it. So here what we try to do, that once this Q is being encountered, once you press Q, then it will try to quit this object detection window. So that is something that we can work around with. And apart from this solution that we have discussed, we also try to get a little understanding of how you can grayscale as well as blur your image. Okay, grayscale and blur image. So we have actually put it on the community platform for you to check it out yourself. Run this two interesting snippet exercise. Also experiment with this third one that is available if you would like to resize an image. That is also possible. So go ahead and do these interesting exercises for yourself. And yeah, I am now open to questions from you guys. So we have two questions coming up. Let me just. So it will take a while for my cam to get connected here. Okay. So yes. So we have two questions from our community members. One is by Akshara, where she asks how you can improve the accuracy of object detection in a video stream using OpenCV. So yes, you can improve the accuracy of object detection by using techniques such as Kalman filtering. So currently we have just used a pre-trained model. You can use different image augmentation techniques which we discussed. You have to train the model using the different techniques such as zooming in, flipping it, or cropping it, and then with so many multiple images that are available is when we are able to get to the most accurate form of object detection. So this is going to get improved slowly, not very easily. But then there are interesting techniques like Kalman technique and so much more. Also, there's another question coming up, wherein one of our viewers have asked how you can use OpenCV to perform feature mapping between two images. Okay, so feature mapping is very important, and that there are two techniques that could be involved. One is your scale SIFT, which is scale invariant feature transform, or you can use speed up robust features SURF. So these involve extracting the key points and descriptors from both the images and then matching them based on the similarity. So once the match has been found, we can use various other techniques like random sample consensus to eliminate whatever outliers and improve the accuracy of the matching. So yeah, I think this should answer your question. And I just want to summarize what we discussed in today's session. We tried to give a brief on how artificial intelligence and computer vision as a whole has been able to give us the capability that we sit here today and are able to capture our own life feed and detect objects and use it for more practical applications, similar applications, and quickly develop this interesting code using Candy Kit by getting all the resources set up in a single, single kit. So I hope this was helpful, and we look forward for more queries. You can put your questions on the community platform.
Thank you, Pooja, for that lovely session. For all our viewers and bootcamp participants, we hope you enjoyed the session and found the use case that was presented valuable. Please note that all of you who participated will be eligible to receive certificates for this bootcamp. In order to receive your certificate, please complete the assessment by answering two very simple questions. You can do that by scrolling down from on the same page where you're viewing the bootcamp today. You will find a Take Assessment button. Click that button and complete the assessment. You should then receive your certificates in less than a week from today. We will be conducting such bootcamps frequently and regularly. So if you'd like to stay updated with our program calendar, do join our community on community.openweaver.com. This community is where we will connect with you. It helps us receive feedback from you. It helps us understand topics for future bootcamps. But also you can use this community space to collaborate with each other, to ask us any questions and receive clarification if you'd like, or just share your projects and anything else that you would like to in the world of open source. So do join our community and also follow us on our social media channels to stay updated on information and trends in the world of open source. With that, I would like to thank you all for your participation today, and I look forward to seeing you in yet another bootcamp very soon. Thank you and good evening.